Okay, this is the second of two videos working on composite volume for our notebook. The question that I wanted you to try on your own is right here, and as you can see, the top cone, if the diameter across the top is 12, you need to substitute in 6 for the radius. It shows a height of 8, so when this gets multiplied together in terms of pi, you get 96 pi. The smaller cone had a radius of 3, so you can see how 3 was subbed in for the radius. When you do all the math in terms of pi for this cone, it's only 12 pi. Combined together, remember, this is composite volume, so we're putting two or more shapes together. Combined together, we get a volume of 108 pi, and it is inches cubed because they did give us inches to begin with. So for that first one, check your answer. For the second one, what's strange is that Bob is building a storage shed in a conical shape. So he's building a cone-shaped shed. Very bizarre. But we're going to go with it. The base of his shed is 4 meters in diameter. The height of his shed is 3.6 meters. So that tells us we can go ahead and plug right in with our height. But remember, our radius is needed in our volume formula. So that's how we know that we are going to take your diameter of 4 going all the way across the circular base, cut that in half to get your radius of 2. So again, if we keep our answer in terms of pi, we're going to type this in without putting in the pi button. We're going to get 4.8, but we write our answer 4.8 pi meters cubed. The last question, you can fold your paper over so that you can do some of the work on the back. It says it uses a funnel in the shape of a cone to fill soda cans that are coming along on a assembly line. The funnel has a height of 10 centimeters, a diameter of 8 centimeters. So I just started out right here with a little picture of what that funnel might look like if the soda was coming down through the funnel and filling in the cans. This is kind of what it would look like. And then I finished on the back by putting another picture. It says the cans that we're filling have the same dimensions. So I tried to sketch a can with the same diameter, with the same height. And remember, you're going to be having these cans coming down the assembly line, but they're going to get filled through this cone. So we need to figure out how many times the machine needs to fill the cone so that this can get filled up. So that means what we have to do here is we have to do some work with volume. And if you remember from the other day, we not only found the volume of a cone, but we found the volume of a cylinder. So I'm just going to tape this down because it keeps flopping up on me. And we'll go through and we'll find those two formulas. Remember, for a can, we're going to use pi times r squared h. But for the cone, we're going to use 1/3 pi r squared h. So starting out, we've got our radius to locate. We've got our height of 10. Down here, again, we've got to figure out what the radius is, but we know our height is 10. What we need to do now is we need to look carefully and remember that if our diameter is 8 centimeters across this width of the can, then our radius is only 4 centimeters for both questions. So if we put in our volume of a cone, 1/3 times 4 squared times 10, remember that's what it's going to look like if you type in all the numbers but do not push the pi button. You're going to have 53 1/3 pi units, and these are centimeters cubed. Now the only difference between what we calculated for the volume of a cone and volume of a cylinder is the cylinder does not need the 1/3 in front of it. So remember, we're still going to type in our 4 squared, we're still going to type in our times 10. You're going to get 160 pi for the volume of the cone. So if we have, of the cylinder. So if we have to figure out 160 divided by 53 1/3, remember to use your ABC button. I think I goofed that up, 160. We're dividing by 1 1/3. Now 53 1/3. 53 1/3. That's what it's going to look like if you use your ABC button properly. The 160 can divided by the 53 1/3 makes 3. It's going to take 3 cone filled with soda to fill 1 can of soda. And this is kind of what we talked about the other day about how the cone, it will take 3 of them to fill up a cylinder with the same size circular base with the same height.